Okay, so we're going to look at this question here. So it says, first of all, the fourth term, U4, of a geometric series is 135. The fifth term, U5, is 101.25. Find the common ratio of the sequence. All right, so we can start with part one. So the common ratio is always the division of two consecutive terms, the later one divided by the sooner one. So I can work out that R is going to be U5 divided by U4. Likewise, it could be U2 divided by U1 or U3 divided by U2. Either way. So it's going to be 101.25 divided by 135. So I can use my calculator to work out that. So 101.25 divided by 135. That gives me 0.75. So there we found the common ratio. So common ratio is 0.75. So next, it says find U1 at the first term of the sequence. So we can do this by using that U n is equal to A R to the n minus 1. So we know, for example, we can use either the fourth term or the fifth term for this. So we could say that let's use the fourth term. So U4, which is 135, is equal to A, or I'm going to write U1 in this case because it's written it as that as U1 for the first term, and then R, 0.75 to the power of n minus 1. So since this was the fourth term, this would be to the power of 3. So therefore, I can say that U1 is equal to 135 divided by 0.75 to the power of 3. Again, I can use my calculator. So I can say it's 135 divided by 0.75 cubed, which equals 320. Okay, so the first term of the sequence is 320. Then it says calculate the sum of the first 10 terms of the sequence. So to work out the 10th term, we're going to use the formula for the sum. So the sum of the nth term is equal to A, 1 minus R to the power of n over 1 minus R. So the sum of the 10th term is therefore going to be what we're trying to work out. So we're going to do the sum of the 10th term is equal to A, which is the first term which we just worked out, 320, and then 1 minus 0.75 to the power of 10, and then divide that by 1 minus 0.75. So the sum of the 10th term is going to be 320, and then 0.75 to the power of 10 is that. And if I make that minus and then add 1, so it's me 1 take away that, multiply that by 320, which gives me 301.979, and then I'm going to need to divide that by 0.25. So it's going to give me that. Yeah, what I should do is just rub that out there. So it's 1,207.9. Yeah. Okay, so there is my sum for the first 10 terms. So I should just leave it like that, I suspect. And there I should have my 6 marks. Okay, so we're going to do another question. This one says the first 3 terms of an infinite geometric sequence are m minus 1, 6, m plus 4, where m is an element of z's, which means that m is an integer. Okay, so part A says write down the expression for the common ratio R. Now, common ratio is always the second term divided by the first term, or the third term divided by the second term, or the fourth term divided by the third term. So I can say that R is equal to 6 divided by m minus 1, and it would also be equal to m plus 4 divided by 6, either of those. So part 2 says, hence show that m satisfies the equation m squared plus 3m minus 40 is equal to 0. So I've got those two different versions of R there that's part 1 of A. So I suspect that what I need to do is use the second two where I've got them equated. There's the 6 over m minus 1 is equal to the m plus 4 over 6, and then rearrange that, and hopefully I'll get that quadratic to drop out. So 6 over m minus 1 is equal to m plus 4 over 6. So I'm going to multiply across by 6 and also multiply by m minus 1. So that's going to give me that 36 is equal to m plus 4 times by m minus 1, like that. Then I can multiply out my two brackets there. So that's going to give me m times m is going to be m squared plus 4m, and then minus m, and then minus 4. Okay, so I can then gather up the similar terms, move the 36 to the other side, and then equate it equal to 0. So I'm going to have m squared plus 3m, because I've got 4m and take away 1m, and then I've got minus 4, and then minus another 36, so that will give me minus 40 is equal to 0. Hopefully that's what we're supposed to get. Yes, that looks right. Okay, so then it says find the two possible values of m. So what we're going to need to do now, that was a part 2, we'll get some more space on our page, and then we're going to need to factorize that and work out what the values of m are. So negative 40, I can factorize that with 8 and 5. 8 times 5 makes 40. And then because it's negative, one of them is going to need to be negative. So I think that the factors should be m plus 8 and m minus 5. Like that would equal 0. That should be factorized. Yes, so therefore m is equal to negative 8 or m is equal to 5. So let's find two possible values of m. Okay, and then I need to find the possible values of r. So r was equal to 6 over m minus 1. R is equal to 6 over m minus 1. So that's going to equal, for the first one, it's going to equal 6 over minus 8 minus 1, which is going to give me negative 2/3. Or for the other one, it's going to be 6 over 5 minus 1, which is going to give me 6 over 4, which is going to give me, I'll write that as 3 over 2. So those are my two possible values of r, this one or this one. Okay, so then it says the sequence has a finite sum. State which value of r leads to this sum and justify your answer. Okay. So when we can get a finite sum, that means that our sequence is going to have to tend to be 0. So when you did the sum to infinity, you should remember that the modulus of r has to be less than 1. So therefore, for a finite series, this is part C. So the one where the modulus of r is less than 1 is the negative 2/3. So it's going to be r is the negative 2/3. That one's going to work, the other one is not going to work. Okay, and then it says calculate the sum of the sequence. So it's got a finite sum, so this means the sum to infinity. So this is what C part 2. Okay, that's C part 1. So C part 2, we're going to need to find the sum to infinity. The equation for our sum to infinity is equal to a over 1 minus r. So that's the equation there. So all we then need to do is just to drop in the values. So do we know what a is? Our first term, no, our first term is m minus 1. So a is equal to m minus 1. And m had to be negative 8 to get the value of negative 2/3. So for r is negative 2/3, m has to equal negative 8. The other value of m didn't lead to the 2/3, so that wouldn't be a finite series. So we need to use the m as negative 8. So therefore, a is going to be negative 9. Therefore, our sum to infinity is going to be negative 9 divided by 1 minus 2/3. So that is going to be negative 9. 1 plus 2/3 is going to give me 5/3. So therefore that is going to be negative 27 over 5. And I think I should just leave it as a fraction like that. Okay, so if you're looking for some more questions, then what you can do is go to my website, which is qualitytutoring.net. If you don't have an account, you can click create account here and create an account. Once you've created an account, you'll then be able to log in and you'll be able to hit the questions tab here, and you'll be able to find a bunch of questions. So I was looking for questions on series, so I selected my topic here as series, and then I selected my subtopic here as geometric series. And I can see I've got 34 questions. I can press the I here, and then I can view the questions. If you want to, you can then sub-select by level, and you can select just IB or diploma program if you're doing IB, or A-level if you're doing A-level, and subdivide them further. But it should be sufficient just to have them like that. The questions are all fairly similar. So I did a couple from IB, and I think I did one from A-level. So there's more questions there for you to look at. If you've paid to subscribe to the site, then you can also see the mark scheme as well, so you can check your answers and check that you have them right. So if you're looking for more questions, then that would be a good place to look.